So we all know what lines look like, but how are they written mathematically? So usually they're given in the form y is equal to mx plus c, where m is just a gradient. I'll explain all these words means in a bit. That's the gradient. C is just a constant, so just a number. We call it a constant. And then of course x and y are just like what we know, like the x coordinates and then the y coordinates. Let's switch over to this tab and draw some lines. So let's say we have, so we're gonna get y and x. Let's say our m is equal to 2, our x is just x, and then let's make our c equal to 1. Right? So m is equal to 2, c is equal to 1. Y is equal to y and x is equal to x. So let's try put some numbers in for x and then we'll get some values for y. So when x is equal to 0, y is equal to 2 times 0 plus 1, which is 1. We put a point over there. When x is equal to 1, y is equal to 2 times 1 plus 1, which is equal to 3. So when x is 1, y is 3. When x is 2, y is equal to 2 times 2 plus 1, which is equal to 5. So 2 and 5. We have another point over there. When x is equal to minus 1, we have minus 2 plus 1, which is equal to minus 1. So we have a point over there. Then we can continue doing this, but then it's going to end up being a line. And the line is going to connect all the points together. It's going to look something like this. So what makes it, oops, let me get that back. Put that line back. Right there. It's gonna go through all those points. So what makes it a line is that you cannot change m. This value for m must stay the same, and the value for c must stay the same. If you change these values, then it's not going to be the same anymore. It's going to be a different line. And if you change c, so let's make c equal to 3, for example. So m is equal to 2, c is equal to, let's make it minus 1 actually. Make it interesting. So then let's put some numbers in for x. So we have 2 times 0 plus, so we actually have y is equal to 2x minus 1. So we don't have this anymore. So we have 2 times 0 minus 1, which is negative 1. So at 0, negative 1, we have a point. And then we have, when x is equal to 1, y is equal to 2 times 1 minus 1, which is equal to positive 1. So we have that point. And then if you keep on putting the numbers in, you will see it ends up looking something like this. Let me just put the numbers in. And then it's going to be another straight line. And it's going to go through these points. So now we've only changed c, and our m is the same. And you can see these lines, they look very similar to each other. It's just like they're offset by a little bit, but they are pretty similar. And that's because they have the same gradient. And that's what m is. M is the gradient. Remember when we went back over here at the start, we said m is the gradient. And if they have the same gradient, then they're going to be parallel lines. So these are parallel lines because m is the same. If the m was different, then a line would look something completely different. So let's say let's draw another line. Let's draw y is equal to negative x plus 2, right? Let's say when x is equal to 0, we would have y is equal to 0 plus 2, which is equal to positive 2. So we have that point right there. Let's say when x is equal to, so when x is equal to positive 1, we have minus 1 plus 2, which is equal to positive 1 as well. So 1 and 1 right here. That point's also already there. When x is equal to negative 1, we have 1 plus 2, which is equal to 3. So we have negative 1 and 3. And then we can connect all these points. And of course, the line looks very different, right? This line is not the same as the other two lines we have. This is because we changed the gradient and we also changed c, which is, c is actually the y-intercept. C is where it crosses the y-axis. So if you look at this line right here, y is equal to 2x plus 1, which is this line, you can see it crosses the y-axis at 1. Y is equal to 2x minus 1, you can see it crosses the y-axis at negative 1. Y is equal to negative x plus 2, it crosses the y-axis at positive 2. So So this c, which we said was a constant, now we can add another thing to it. Now we know more about it. It's also known as the y-intercept. Right, so now we know about parallel lines. Now we need to know about perpendicular lines. So actually, before we even go to perpendicular lines, let's do this. Let's say we had a line given to us. So let's say we had this line right here, y is equal to minus x plus 2. How do you find the equation of that line? So we already have a line given to us, so now line is given. Before we were drawing lines, now we already have the line. How do you find the equation of this line? Well, we know y and x are just going to stay as y and x, so we don't need to worry about these. We need to find m, and we need to find c. Well, c is easy. C is the y-intercept. Y-intercept. And we already know this. So we can just look at the line and we can be like, oh, 2. It crosses it at 2 over here. So we're looking at y is equal to minus x plus 2. So we already know it's going to be y is equal to m. We don't know m yet. We have to find m. We know x is just x. And then we know it's minus 2 because that's the y-intercept. How do you find m? So the formula is we take any 2 points on the line. So let's take the point 2. Oh, we're not doing this line. We're doing this point. We're doing this line. So let's take the point -1 and 3. So we have point A, which is -1 and 3. And then let's take a point B to be, let's take 4 and -2. 4, -2. The way you calculate m is you do the second y-coordinate minus the first y-coordinate. That's -2 minus 3. And you divide that by the second x-coordinate minus the first x-coordinate. So that's 4 minus -1. So that's -2 minus 3 is -5. And then 4 minus -1 is +5. So you have -5 divided by +5, which is equal to +1. And that should be our m. So you should have y is equal to, oh, that should be -1, sorry, not +1. -5 divided by 5, which is equal to -1. So then you have y is equal to, well, our m is -1, so -1x minus 2. Or plus 2, actually. Why did I do minus 2 there? Should be plus 2. And you can see that is the equation of our line. Y is equal to -x plus 2. Y is equal to -x plus 2. So let's do an example. Let's do an example question. So C is the point 5, 1, and D is the point 13, 15. Find the midpoint of CD. Okay. So the midpoint is just the halfway point between C and D. So let's say our line, we don't need to know what it looks like, but let's say it looks something like, let's say C is 5, -1. Let's say C is right here. And D is 13, 15. D is somewhere over here. That's D, right? We don't need to know what it looks like. All we do need to know is to find the midpoint, which would be somewhere over here. Well, we just need to find the average of these two numbers. So we do 13 plus 5 divided by 2. With 13 plus 5 divided by 2 because 13 is one x-coordinate and 5 is the other x-coordinate. And that is equal to 9. And then for the other point, we have 15 and -1. So we do 15 plus -1 divided by 2, which is equal to 7. So our x-coordinate is 9, and our y-coordinate is +7. And that's the midpoint of CD. Find the gradient of CD. Well, we said m is just the second y-coordinate minus the first y-coordinate divided by the second x-coordinate minus the first x-coordinate. So we already have the things given to us. So we have 15 minus -1 divided by 13 minus 5. 15 minus 1, 13, and 5. And then you end up getting 16 divided by 8, which is equal to +2. That's the gradient of our line. Our gradient of the line is 2. That's pretty easy. Find the equation of the perpendicular bisector of CD. Give your answer in the form y is equal to mx plus c. So perpendicular bisector. So perpendicular, if you ever see this word, perpendicular perpendicular. Or if you see the word normal, they all mean at right angles. They both mean the exact same thing. This all means at a right angle. And a bisector just means to cut in half. Well, we did find the midpoint over here, so maybe that's going to help us in this question. Let's see. So I'll tell you right now that let's say we had this line right here, right? Let's say its gradient, which is m, is equal to 3. A perpendicular line to this line would look something like this, because it would form a right angle with that line at that point. You can see it forms 4 right angles. And the gradient of this new line, this line right here, is going to be -1 divided by whatever this m right here is, so 3. It's going to be -1 over 3. Similarly, let's say we had a line that looks something like this. Let's say we had a line that looked like this. It had a gradient of -2, for example, right? So the perpendicular line will look something like this. Let's say that's a right angle, and its gradient would be equal to -1 divided by this thing right here, which is -2. So -1 divided by -2, which is equal to +1/2. So that's how you find the gradient of a perpendicular line. Find the equation of the perpendicular bisector of CD. So how would you do that? Okay, let's think. So going back to our CD. So now we know our line looks something like this. Let's say that's a line, right? So the perpendicular bisector will form a right angle with the line. And also it will be at the midpoint of C and D because it's a bisector. So it cuts this line right here in half. So that's the whole point of finding the midpoint, because now it's going to help us to find the perpendicular bisector of this line. Well, so we now know the coordinates of this point. Let's call this point E. And we know E is 9 and 7. And we also know the gradient of CD, which is 2. So equation of the perpendicular bisector is y is equal to mx plus c. So we need to find m, and we need to find c, question marks. Well, we know m, right, is -1 divided by 2. So we'll have y is equal to -1 divided by 2x plus c. How do you find c? Well, we know the points 9 and 7 are on this line. This new line right here, this line, has the point 9 and 7 on it because it goes through it. Well, we can just put 9 and 7 in for the numbers, for y and x. So y is 7. Let's put it down a bit. Y is equal to 7. 7 is equal to -1/2, and x is equal to 9 plus c. Well, we can simplify that. Y 7 is equal to -4.5 plus c. And bring the 4.5 to the other side, you have c is equal to 11.5. Well, that's it. That's all you need to know. So now we have y is equal to -1/2x plus 11.5. That's the same as 23/2 if you want to give it in fraction form. Since I gave it as a fraction here, I'll give it as a fraction here. But 23/2, 11.5, of course, is the exact same thing. So yeah, that's what we need to know about lines. So now we know something about gradients. We know about the equation of a line. We know about the y-intercept of a line. We know about parallel lines. These have the same gradient. We know about normal or perpendicular lines. These are -1 divided by the original gradient. For the gradients, we know how to find it. We know how to draw the lines. What else? We know what a bisector is, because we calculated midpoints. And we know how to find the equation of a perpendicular bisector of a line. So yeah, that's an introduction to lines.